Right. This is going to be a short video saja. I'm just going to show you how we can use a product from ChemAxon ni. Not just in our teaching lah. For today I'll just show how it's. I think it is useful lah for teaching. Then of course for research as well lah. ChemAxon ni actually a company that deals with chem informatics lah. Jadi maknanya it has a sketcher. Sketcher tu macam ChemDraw, ChemSketch lah. But more than that, it's not just for drawing structures. It can read and save structures, disassemble molecules, and most importantly, it can actually do a lot of other things yang berkaitan dengan chem informatics. So it's basically an interface to do a lot of other things lah. Yeah? One of the most important thing is to generate molecular fingerprints. So molecular fingerprints ni untuk you use it for generating descriptors lah of molecules, and this will be useful for any QSAR or QSPR studies lah. Yeah. Okay, so the thing that we're going to look at is ChemAxon. Yeah. So ChemAxon is a company that produces toolkits used in the field of chem informatics. This is Windows based. Most data scientists, they would use other toolkits ya yang kena buat programming kan, but this one ni tak payah program. It interfaces seamlessly with Excel, Word, PowerPoint, so you can actually use all the Microsoft Office suite program kan, together with ChemAxon. So it's actually going to be a part of the add-on lah. But of course, in this talk, we're not going to look at everything. We just look at some of the functionalities lah. I myself, I'm still learning about this software. There's so much to learn about this. I will just show you some of the things that I think would be useful for teaching. Yeah. Okay, so the first thing that you have to do is to log in to the ChemAxon site lah. Yeah. You can log in. Jadi you have to create your username lah. Because ChemAxon is it's a free software, but it's a licensed software. Free for academics. That means you have to apply for academic license. Most of the things that they offer, because it produces toolkits, means that different types of programs for different types of usage within the chem informatics field. So you can actually download any of the toolkits and use them. We will just try two of the toolkits because the two actually integrates many of the functionalities of what ChemAxon has to offer. But you have to log in first, so create your username and everything, because after downloading, you need a license, so you have to apply for the license. Make sure that you use your email, because they want to make sure that you are from an academic institution. Okay, so if you use this for research, for example, you have to make sure that you quote ChemAxon that you're using it. Yeah. Okay, so logging in, kalau you click at the product field, so there are a few toolkits, a few programs that you can actually download. They are divided into standalone applications, toolkits and components, and third-party integration. So we are going to look at, first of all, the standalone application, and we are going to download Marvin, which is a chemical editor. So with Marvin, you can get access to all the other components. And then we are going to look at, we're going to download JChem for Office, right? So there's a light version. With the light version, a lot of functionalities are not present, but you can still use it lah. You can try both if you want to. Anyway, I have JChem for Office. It's a bit heavy. So if your laptop is a bit slow, then it will be quite heavy because there are a lot of things inside. Yeah. What we're going to use is basically JChem for Excel. In Word, PowerPoint, and Outlook, you can still integrate chemical structures and chemical intelligence into your Word and PowerPoint and Outlook. But I think the most important thing is to integrate intelligence or chemical intelligence into Excel. Yeah? So you have to download two things. First of all is Marvin Sketch, Marvin, and JChem for Office. Okay, so register, login. And then once you have logged in, you apply for the academic teaching software from ChemAxon. And you need to log in for this. So these are the three links that you can have. First of all is the registration and then downloading it. Number two and number three is to apply for the academic license. Yeah? So the first thing is Marvin. These are there are a lot of tutorials dalam internet, in the web, in YouTube. Very very good tutorials lah. There's a user guide. Okay, so you can go through one by one, and there are of course lots of videos related to Marvin. Yeah? What we're going to look at is basically the idea of enumeration. So because ChemAxon is a chem informatics company, and the software that we downloaded is basically uh, chem informatics software. So there are a few things that is used by chem informatician, and amongst the most important things are uh, uh, combinatorial chemistry. Yeah, which means you want to create as many structures as possible. You can create millions, if not structures, yeah, for you to use in your screening. Yeah. So the way you can do that is by what's known as the Marcuse enumeration, where you create a Marcuse structure. Maybe organic chemists will know about this. You create a Marcuse structure with all the things that you want to put in the structure, and then you generate the different structures. Yeah, and you can have a lot of structure. So the idea that we are trying to implement here is to actually use combinatorial chemistry to generate a lot of molecules with certain functionalities that we require, so that we can personalize or individualize exercises, yeah? For students, in terms of reactions ke, ataupun maybe structural features. You know, bagi tanya student, ask them about stereochemistry ke whatever. So you can generate huge amounts of compounds, and you can actually individualize their ni lah, assignments. So first is Marcuse enumeration, and then we're going to look at chemical reaction. We're not going to draw a chemical reaction. You can do this as an organic chemist. You draw a chemical reaction. You can map the atoms, and using that chemical reaction template, you can then generate another type of enumeration, which is enumeration by reaction, and you can generate again hundreds of thousands, millions of compounds if you want to. Some compounds are not even, they don't even exist. Yeah, but you can generate them, and maybe you can get students to do, or to do synthesis. Up to you lah. It's organic chemists will know more about this. Yeah. So ChemAxon itself prepares a reaction template. There are about 250, I think, reactions templates, and you can just use those templates to generate molecules for your exercises for students. Yeah, individualized exercises. Okay. For JChem for office, we are really going to use Excel. One of the ways to actually do the enumeration. Kita akan buat enumeration. We're going to use the Marvin itself to enumerate chemical structures, and we can also use Excel to do the reactions. Yeah? So when you install JChem in Office for JChem, JChem in Excel, uh, included in the JChem add-in are all the formulas related to JChem, which you can use. Okay, there are many of these functions, hundreds of them. Well, if you want to, you can learn everything, lah. But well, what we're going to use is just things that we feel is going to be useful for us now. So I think the most important thing is to when you integrate, when you put or install JChem into Excel, your Excel now becomes chemistry centric. So you can actually deal with chemical structures, yeah, rather than just numbers and text. Okay, so let's have a look at how we can do this quickly. Now again, I'm still learning this software, so there are things that I myself I'm not sure, but I'll just try and see if we can actually do something with this. Okay, say we want to create, uh, I don't know, carboxylic acid, I suppose, or an amine. Yeah, you want to create an amine, and you just want to create as many amine structures as you want according to what you define. Okay, so we can start with nitrogen there, and carbon. This is just, I'm just playing it around. Okay, no planning here, just simply doing it. Yeah, doing things. Just put another one there. Okay, and so in a reaction that involves amines and carboxylic acid, you have to have one hydrogen, right, left. So what we do is we put a link, not list, atom list, right? Atom list, so that that can either be a carbon or a hydrogen there. Okay. So what will happen here is it can either be hydrogen or carbon. Okay. And then we'll put a link so that we can expand this part. Yeah. We just three carbons. So what will happen is it can either be one carbon to three carbons will be connected here. And then maybe we can add um, we can add halogen there. Hold on. L B R H F. Okay. Oops, sorry. Bad mouse, bad mouse. Oops. Okay. So R1 will be here. Okay. So it's either Cl, Br, or F. What else can we change? Um, let's have another carbon there. And we put this is just creating it as I go along. We put an error group here. Okay. So with this, I will then generate the Marcus structures. Structure Marcus enumeration. Okay. Okay. Based on what I've created here, I can ask the program how many molecules will there be. So I click the Marcus library size, and it tells me that very slow. But it says that there are only 18 compounds, so it's okay. Yeah, sometimes when you put different substitution possibilities, the library size will just increase tremendously. So if it is just 18, we'll just do a sequential enumeration and generate all enumeration with the arrow. Let them enumerate the homology groups as well. And we press OK. So it will generate all the 18 structures. Computer is a bit slow. Okay, while waiting, are there any questions? Wait, why is it 1,000 structures? There are 1,062 structures. Oh, because I enumerate the homology groups, okay? So once I click enumerate homology, the aryl, whatever aryl structures that ChemAxon has, it will substitute into the compound. Yeah? So we have all these different structures based on what we started off with, the Marcuse structure. Huh? There you go. So maybe we don't want all of them, we just want some. So just random enumeration, say 10, okay. We should just get 10 randomly enumerated compound based on this Marcuse structure. So you can also draw, say for example, this is amine. You want to react amines with carboxylic acid. You can then do another carboxylic acid set of compounds. Up to you how what is the structure going to be. And well, what we can do is we can save all. Save all. I prefer to save it in the MDL format. Okay. Amines in the desktop. Okay. So it will save all the 10 structures on the desktop. Okay. Oops. Okay. So now what we can do, we can go to Excel. Right. See, we want to react the 10 structures with carboxylic acids. Okay. So we can start with going to the GChem menu. Then we import from that file that we have just saved the amines. Open. We overwrite. Not create header. We want the molecules to go down the row. Sorry, the column. Yeah. Next. Structure only, and we import. Oh. Yeah. Okay. So we have the structures coming in column A. Yeah. So in order to react with carboxylic acid, we need to actually insert another one. So we're going to put carboxylic acids here. Yeah. So you can do the same thing, yeah, with the Marvin, and create a Marcuse structure of a carboxylic acid that you want. Generate the carboxylic acid, and then you paste it here. Transposed. Yeah. Transposed means if you have usually when you keep data, the data goes down from row 1, 2, 3, 4. So if you want to fill it in columns, so they have to transpose. So you paste as and transpose the data that you have. And then you can react it like multiplying, like multiplication. This multiplied by this multiplied by this, and you have uh, your your products. Yeah? So you can do that. Um, or now I'm going to show you another alternative way of doing things. We can use Marvin Sketch, but okay, we'll forget about Marvin Sketch for a while. We can actually search structures in on the internet. Yeah, so we can use PubChem. Now we already have amines, right? So we want to check the carboxylic acid from PubChem. Yeah? Acid. Now, of course, PubChem, you can actually search either with keywords, or you can draw the structures, yeah, upload the IDs, many different. It accepts keywords, it accepts smile strings, it accepts inchi, um, even the molecular formula. Yeah? So many different ways of searching. Carboxylic acid. So of course there will be millions, lah. Yeah? So there are millions of these carboxylic acids. I'll go for substances, for 1 million. So these are the carboxylic acids. Now I want to, for the purposes of doing this, we just need 10 of those. So we go for, we make it search in Entrest, which is a different searching engine. But basically I think it has more extensive database searches. Yeah? And one good thing is that you can actually choose what you want. Yeah? So I can choose a few of the carboxylic acids that I want. see, I'll choose about 10 of those and download PubChem. Okay, done. So download. So I've chosen 10 results. Again, I'll use the SDF format. So it's downloaded there. Hold on. I need to go to the this is in download folder, right? So in folder, PubChem cache XBV6. XBV6. Okay. So now we go back to Excel. And we want to stick all the carboxylic acids here, right? So we go back to JChem and import the file that we have just downloaded. That file is in the download. Right, there it is. Okay, we are going to overwrite and we're going to start at the current cell, which is B1. We won't create the header, but we're going to transpose what we get. Okay, next. Now, when you download the file from PubChem, it gives you all sorts of things. Yeah, we don't want any of those. We just want the structure. Okay, and we start to import. So what we're going to get are carboxylic acids there. So we have amines there, and we have carboxylic acids there, right? Okay. So what we do is we want to react this each and every one of those, like just like multiplying them together. Now, in order to do that, I have to define the type of reaction here. Okay. So I'll go to JChem again. I will insert the reaction type. Okay, the reaction type is something that you have to download from the internet. In ChemAxon site is the reaction library. Yeah? Okay, where is it? C, I think. Program files, ChemAxon reaction library, right? So we are looking for an amine reacting with carboxylic acid, which is amide formation. So there is actually an amide synthesis from carboxylic acid. Okay, so that is the defined reaction. So just to remind you, you can actually write your own reaction if you want to. So what you can do is you write your own reaction, and then you map the atoms, right? So for example, when amine and carboxylic acids react, you get an amide plus H2O. So you don't have to draw the H2O. You can still draw the H2O. If you draw the H2O, then you have to define the atoms, and you have to map them. So in this case, if you look at the atoms, this carbon there, number 2, is mapped to the product number 2. Yeah? So number 7 will be gone. That will be part of the H2O. And N4 is there. The link atom, either a carbon or a hydrogen, that's number 5. It's placed there. Yeah? So you can create your own reaction if you want to. You can map them and use it as a template. Yeah? Save it, yeah? and you can actually enumerate structures based on reaction like this. Okay, once you've done that, so I want to react this with this. Okay, now this one should work. It should work, I hope. So we go to, sorry, you don't have to go there. You go to FX, which gives you all the formulas. And the category is JChem Excel functions, okay? Now, inside JChem Excel function, there is a function, a formula, which is related to the React toolkit. So the toolkit is included in JChem. That's why it's a bit heavy. So it's included in JChem, JC React. Is it JC React? There you go. JC React product structure. Okay. Now the parameters of JC React product structure is the reaction. This is the defined reaction A1. Reactant 1 is the carboxylic acid. Reactant 2 is the amine. And it should give us a structure, hopefully. Yeah. So this is an amide. Yeah. Now I want to just copy and paste to everything. So I have to do something about the formula first. So A1 doesn't change. So you have to make sure that this is absolute reference. Absolute reference. F4. Okay. $A, $1. If you talk about the column, so B doesn't change, right? But 1 will change. 1, 2, 3, 4. Okay. So we'll just lock the B. Lock the B. And for this one, we'll lock the number, which is the row. Okay, so I will go down, see what happens. There's my product. Oh, invalid. Ah, okay. There first. Invalid reactant 2 structure. Invalid. This structure is invalid. Why is it invalid? Never mind, we'll just go and see what happens. Invalid. Something is not right. So only this one works. Yeah. What we can do is we can actually replace the amines. Just let's search for the amines rather than drawing it. This one is it involves experimenting with things. Huh? Let's search for an amine or many amines. Right, and choose the amines. Right, 10 amines, for example. 5, 6, 7, 8, 9. Download in PubChem. And download. Yeah. Right. Okay. That's done. Let's go to Excel again. And we want to replace this. Yeah, I'm not sure why it's invalid. Very odd. Hold on. $B2. Oh, okay. Right. This one should be, I'm sorry. I should have locked the number rather than the B. It should work now. I hope it works. Now if I go down, what happens? Yay, it works. So here, and we have all the amides. There you go. And we go down. Yeah. So some of them have no products because it doesn't um, follow the structures of the reactants don't follow the reaction template. Yeah? So we'll go back to what we were doing just now. Yeah? So we got the amines. We've downloaded it. I think we have downloaded it, right? Yes, we have. Oh, we haven't. Oh, we have. Right. cell. We just want to change this. This is the ones that we draw. We want to change it with the one that we actually searched. So go to jchem, import, import the structure that we have just imported just now, which is this one. Okay, so we're going to overwrite, start at current cell, don't create the header. Next, we just want the structure, and we import. And it will change to the amines that we searched rather than, okay, so there you go. So you see all the other structures, the reacted structures have changed. Yeah? Okay. So yeah, so there are two ways of actually doing enumeration. One is by drawing the Marcus structure, and the other one is by reacting. Yeah? If you know the reaction that you want, you can create all the structures that you need to create. So you can, with all these various structures, this is a bit messy, lah. But if you want to teach students to identify reactions, for example, doing retro reaction, then you can use this as a resource where you have all the structures you want, and you can individualize, personalize your questions. Okay, that is all I want to share. I mean, of course, there are other things which are quite impressive of this software, but it's up to you to learn. You can do a lot of things with it. I'm not an organic chemist, so organic chemists will know better, and you will actually be able to use the software much better, uh, not just in teaching, but also in your research. Yep, that's it.